In 4.4, we're going to be factoring polynomials. This is part 1 of the video. We're going to be factoring using the greatest common factor. So anytime you see a greatest common factor, you need to take it out. So greatest common factor, GCF. We're also factoring using the sum of cubes or the difference of cubes. So we have that formula that we need to know. And then the third way we're factoring in part 1 is factoring by grouping. So in the first video, we're just doing these 3 types of factoring. So in the past, we've factored quadratic polynomials. Anybody remember what quadratic means? When our highest term is x squared. That's a quadratic. So we've had x squared plus x plus a number, and we factored it into our 2 parentheses of binomials. Now we're going to have higher than an x squared term, and again we are going to factor it into our parentheses. So this brings us to our first example. In example 1, we need to find a common monomial factor. So anytime we see a greatest common factor in any of our problems, the first thing we need to do is take that out. So looking at A, what can we take out here? What do all 3 of these terms have in common? An x. Okay, so when we take out an x, what are we left with in our parentheses here? Perfect. X squared minus 4x minus 5. Now we have a quadratic equation in here that we know how to factor. Do we have 2 factors of -5 that add up to -4? What would it be? -5 and 1. Perfect. So we're just going to leave that x that we pulled out in the beginning outside. Then we have our 2 parentheses. What goes inside our first parentheses? X minus 5, and then? X plus 1. Remember, the signs that we put, that plus or minus in there, come from the signs here. So since it's a -5, we have to put minus 5. Since it's a positive 1, we put plus 1. And then we're done. This is as much as we can factor. So that's our answer. All right, let's look at part B, question B. Do we have any greatest common factors here that we can pull out? How many y's? 2. If this one has 5 and this one has 3, what's the greatest amount of y's that we can pull out?
3.
3. So we can take out 3 from here, so then we're only left with 2, and if we take out all 3 from here, we take out all of them. Do we have any numbers that we can pull out? Okay, so somebody asked, why can we take out 3 y's? I'll show. It's kind of easier to see when you expand it. So in the first one, we have 3 and y to the 5th power. So we have 5 y's here. 1, 2, 3, 4, 5. Minus 48, and then 3 y's. So if we take out 3 y's, I'm taking out all 3 here and only 3 from here. So that's why I can take out 3. So then I'm left with 3 and 2 y's in the first one, and then no y's in the second one. If I multiplied this y cubed back out to these 2, I would get what I started with in the original, which would be 3y to the 5th power minus 48y cubed. Make sense? Okay. So going back to the start up here, can I take out any numbers? What number do I have in common between both of these?
3.
3. So I'm going to take out a 3 also. So I took out a 3 and 3 y's from here. So what am I left with for our first term?
Y squared minus 16.
Y squared, and then I took out a 3 and 3 y's, so minus 16. Perfect. If I multiplied this back out, I would get the same thing that I started with. Now can we factor y squared minus 16?
Yes.
Yes. What would it be?
Positive 4, negative 4.
Awesome. So we have y plus 4 and y minus 4. So here we could just see that our two factors of negative 16 that add to 0, because we don't have a number in the middle, so that would be like 0y. So two factors of negative 16 that add to 0 would be positive 4 and negative 4. So that's how we got x or y plus 4 and y minus 4. So this would be our final answer here. Okay, so C. Do we have any greatest common factors that we can pull out? What?
A 5 and z squared.
A 5 and z squared. So the greatest amount in common of z's that we have would be z squared. So we can take out 2 z's out of everything and a 5. So what would we be left with?
Z squared plus 7z plus
What's 30 divided by 5?
6.
So 6z. And then 45 divided by 5? 9. So again, if we multiplied this 5z squared just to check our work and see if we did it right, multiplied it times everything in our parentheses, we would get the same thing we started with. We have one more step to do before we're done. So we need to factor our quadratic that's inside the parentheses. One more step. Do we have two factors of positive 9 that add up to 6?
Yeah.
What would it be?
3.
3 and 3. So here we have z plus 3 and z plus 3. So this would be our final answer. All right, 3 more examples. Number 1, do we have any greatest common factors we can take out?
Yeah.
What would it be? X. Then what are we left with?
X squared minus 7x plus 10.
Perfect. So we just divide an x out of everything. So we have x squared minus 7x plus 10. What do we do next? Factor. Do we have two factors of 10 that add up to negative 7?
Negative 5 and negative 2.
Perfect. Negative 5 and negative 2. So what would go into our parentheses?
X minus 5, X minus 2.
X minus 5 and x minus 2. Then we're done. Alright, number 2. Do we have any greatest common factors we can take out?
Yeah.
What can we take out?
3 n to the 5th.
We can take out a 3 and n to the 5th power. So then what are we going to be left with?
N squared minus 25.
Perfect. N squared minus 25. So we just keep this 3n to the 5th power outside. Do we have two factors of negative 25 that add up to 0?
Positive 5 and negative 5.
Positive 5 and negative 5. So what goes into our parentheses?
X minus 5, X plus 5.
Perfect. X minus 5, x plus 5. Any questions on this one? All right, number 3. What's our greatest common factor that we can take out? Can we take anything bigger than 4? 8. So we can take out an 8 from everything. Do we have any m's in common? M cubed. So we can take out an 8m cubed. So then what would we be left with in our parentheses? M squared. What comes next? Plus 1. So we divided 8m cubed from everything here. So 8m cubed divided by 8m cubed would be 1. We can't forget about that plus 1 there. That makes a difference. So now we factor our quadratic here. Do we have two factors of positive 1 that add up to negative 2? Negative 1 and negative 1. Awesome. So what goes into our parentheses? M minus 1 and m minus 1. Awesome. What was that, Brooke? Oh yeah, my bad. This should be 8m cubed. All right, any questions from this page? All right, next we have some special factoring patterns. So we have the sum of 2 cubes. Anytime we see some number cubed plus another number cubed, we can factor that out into this here. So it would be a plus b, so whatever this number is, plus this one, times a squared minus a times b, plus b squared. You guys are super lucky that you don't have to memorize this because you get notes for your tests and quizzes, so that's nice. So this is just a special factoring pattern, and then we have the difference of cubes, which would be if we had a number cubed minus another number cubed, we would put it into this one here. So the only difference between these is the signs in the sum of cubes go plus, minus, plus, and then the signs in the next one go minus, plus, plus. So everything else is the same except the signs change. So let's do some examples. So for A, is this the sum of 2 cubes or the difference of 2 cubes? The difference, because we're subtracting. So we need our A, which would be the number here that's being cubed. So what would our A be? That would be our B. So I'll write the formula again here. So if we have A cubed minus B cubed, we factor that into A minus B times A squared plus A times B plus B squared. So first thing we need to do is find out what our A is and what our B is, and then we plug that into our formula. So what's our A? We're looking at this one for our A. So our A would just be x, because here we have A cubed, so our A would be just x, because then our A cubed would be x cubed. You see that? Everybody with me? Okay, so now for our b, we're looking at this one here. So what would be the cubed root of 125? What number cubed gives us 125? 5. So if we cubed b and got b cubed and cubed 5, that would be 125. So b cubed is equal to 125. Perfect. So b is just 5. Now we take our a and our b and plug it in. So first we start with a minus b. So what would that be? X minus 5. And then a squared. So x squared plus a times b, 5x, plus b squared, what's 5 squared? 25. So yes, that would be 5 squared, which would just be 25. So this is as far as we can factor it. So anytime we see the sum or difference of cubes, we just need to find our a and our b and plug it into the formula. So this was the difference of cubes. Our sum of cubes formula is the same thing, but the signs change. So a cubed plus b cubed is equal to a plus b, a squared minus a times b, plus b squared. So now looking at example B here. First things first, do we have any greatest common factors that we can take out? Any greatest common factors that we can take out? S squared. So then we're left with 16s cubed plus 54. Do we have any numbers in common that we can take out? Two. So 2s squared is our greatest common factor. What are we left with in the parentheses? Perfect. 8s cubed plus 27. So we just divided everything in our original starting problem by 2s squared. So we took out our greatest common factor. So this 2s squared that we took out is just going to stay in the front, hang along for the ride. Now, do we have the sum of cubes here? Yeah. So what's our a and what's our b? What would our a, what's our a? So that's our a cubed. This is our a cubed. So we're trying to find the cubed root of it. So a cubed is the first term, so that's 8s cubed. But we're trying to find what a is, so we need to take the cubed root of both sides. Perfect. So a is equal to 2s. Because if we cube 2, that would give us 8. And if we cube s, that gives us s cubed. So a is 2s. And then what would our b be? If we have b cubed is equal to 27, and we're taking the cubed root of both sides, what number cubed gives us 27? Let's go back to finding all of our factors of 27. This would be 3 times 3 times 3. We take out the group of 3's because it's the cubed root. So that would be 3. So b is equal to 3. once we have our a and b, we just plug that into our formula. So, gotta start with our 2s squared, that just stays out front. Then we have a plus b, so what would that be? 2s plus 3. Then our a squared. So what would 2s squared be? Because we're squaring the 2 and the s. Perfect. 4s squared. Then we have minus a times b, so 2s times 3. 6s. And then b squared. 9. So this is our final answer. So anytime we see two perfect cubes that are being added or subtracted, we just find our a and our b and plug it into the formula. Just remember, there's a different formula for the sum of cubes and a different formula for the difference of cubes. Any questions here? All right, we have one last thing that we're going to do today. That is factoring by grouping. This is like my favorite way to factor. So, first thing we need to do is pull out a common factor. If we see one, that's always our first step, is pull out the greatest common factor. Then, if we have 4 terms, so here we have 4 terms in this example. If we see a number in common in our first 2 terms, so that r is in common, we would take out the r, and we'd be left with a plus b. If we have a number in common in our second 2 terms, which we have an s in common, we would take out an s, and we'd be left with a plus b. So then we would break this up into r plus s times what was in common in both of these, so that a plus b. This will make more sense when we do it in examples. But anytime you see 4 terms, most likely you're going to factor by grouping. Let's go to example 3. So here we have 4 terms. It tells us we're going to factor by grouping. But we see that we have 4 terms, so we know we're going to factor by grouping. So we start with our first 2 terms here, and then our second 2 terms would be here. What do we have in common in this blue parentheses? What can we take out in our first 2 terms? Z squared. So then what would we be left with? Z plus 5. Now what do we have in common in this pink parentheses that we can take out?
4.
We could take out a 4, but then what would we be left with in our parentheses?
A negative.
We would be left with negative z minus 5, and we need the parentheses here to be the same as the parentheses here. So what can we take out to make it a z plus 5? Negative 4. So now in our parentheses we would have z plus 5. So we have to have our parentheses be the same thing. So now we take the blue terms that we pulled out, so z squared minus 4 times z plus 5. So we only have one of those z plus 5s. Now this one we can do it one more step because we have the z squared minus 4. Do we have 2 factors of negative 4 that add up to 0?
Negative
-2, and +2. So what would we get here in our parentheses? Z minus 2 and Z plus 2. And then we still have that Z plus 5. So this is our final answer. All right, there's one more example of factoring by grouping that is on, not the next slide, but the one after. So skip the next slide and go to slide 10. Looking at number 7. Actually, we can do 6 and 7. So 6, we have 4 terms, so we know we're going to factor by grouping. So we take our first 2 and our second 2. What do we have in common in our first 2 terms? X squared. So then what are we left with when we take out an x squared? X plus 4. What do we have in common in our second parentheses? -1. Perfect. So we take out a -1. What are we left with? X plus 4. Awesome. We needed the same thing in our first parentheses as we have in our second parentheses. So we're good. We absolutely have to have the same thing in our parentheses for this to work. So now we can take this x squared and this -1 and put it in its own parentheses and multiply that by what's in common, so x plus 4. And since we have x squared minus 1, can we factor that more? Yep. So what are 2 factors of -1 that add up to 0? -1 and +1. So this is x minus 1 and x plus 1 times x plus 4. Okay, and our last example we're going to do for the day is number 7. So again, we're factoring by grouping here. So what do we have in common in our first pair that we can take out? Y squared. So what are we left with? 3y plus 1. Perfect. What do we have in common in our second pair that we can take out? A +3. So what are we left with? 3y plus 1. We need to just make sure that we have the same thing in our parentheses. So we're good. We can factor by grouping. So we take this y squared. So we take this y squared and the 3. So that would be y squared plus 3. And what goes in our second parentheses? 3y plus 1. Can we factor y squared plus 3? No. Nope. So we're done. This is our final answer.